So we're going to finish off this chapter of solving equations by looking at how to solve absolute value equations. Now, these might look really weird, obviously with the absolute value, but the way that we solve them is pretty straightforward. So I'm going to give you a general example up here. Let me move this just a bit and show you what we're working with. This goes for any absolute value problem that you may see. If I give you the absolute value of x plus a equals b, you're going to basically drop the absolute value bars and solve this equation and see what you get. And then you're going to do this next one. You're going to drop the absolute value bars, but you're going to solve for negative b. You're going to make the other side the opposite sign, and then you're going to solve accordingly. That's pretty much how we solve negative, or not negative, that's pretty much how we solve absolute value equations in a nutshell, assuming that b is positive. Okay, b has to be positive. The absolute value operator, if you remember, just gives us a positive value. If I asked you, what's the absolute value of -6? That would be +6. So you can never get a negative value after taking the absolute value of something. Okay, so with that in mind, with that very, very brief introduction in mind, let me show you how we actually go about solving these using this exact idea up here. So let's start with the leftmost one, and let's get some space for it and zoom in. So if you look, we don't even have to do anything. What you want to do first is make sure that your absolute value expression is isolated. It's by itself. There's no coefficients going on. There's no, +2 over here. And there isn't. Everything is fine here. This other side is positive, so we can go ahead and solve this like normal. So we're going to drop the absolute value bars and solve this. We're going to drop the absolute value bars and solve for our possible second solution by making the 12 negative. And this is just, a simple one-step equation. I subtract 5 from both sides, and I get x equals 7. Do the same thing over here, subtract 5 from both sides. My handwriting's pretty bad, sorry. And we get x equals -17. Now let's double check. If I plug in 7 up here, 7 plus 5 is 12. The absolute value of 12 is 12. That's true. -17. So -17 plus 5 is -12, but the absolute value of -12 is +12. So both of these would be our solutions. And that's it. It's as simple as that. So that one was pretty straightforward. What you do is just make sure the absolute value expression term is by itself, and then you just drop the absolute value and solve like normal. Drop the absolute value and solve, but before you do that, make the other side the opposite sign. Okay. So let's look at one where it's not so obvious what we're doing for that. So let me move this over just a bit so we get a little more space. Bear with me 1 second. So let's say we had this one right here. If you look, we can't just go ahead and say, all right, let's drop the absolute value bars and get to work. We've got a little bit of something going on right here. So that's just 2 times this. So we can actually just divide by 2. And now what we're looking at is the absolute value of 4x minus 6 is equal to 9. 9 is positive, so this is perfectly fine. If we ever do something and we get a negative, like an absolute value is equal to a negative number, boom, right away I want you to think there's no solutions. Absolute value can never give us a negative number. Okay, so let's go ahead and solve this one. The first possible solution would be 4x minus 6 equals 9. The second solution would be 4x minus 6 equals -9. And again, if you look, these look like normal linear equations that we've been solving. So I'm going to add 6. I'm going to let you work through these, and I want you to know how to do these. At this point, you should know how to do these. If you're not sure where to go from here, go back and look at our 2-step equations video or multi-step equations as well. But from here, on the left possible solution, I'm going to add 6. We get 4x equals 15. X is equal to 15 divided by 4. Now, that's not a very fun one to plug in, but what's nice is if I plug in 15 divided by 4 for x, 15 divided by 4 times 4 is just 15. 15 minus 6 is just 9. So that works. Now, if we come here, we do the same thing, add 6, get some negative numbers, that's nice. And we get this right here. It looks like x is equal to -3/4 after we divide both sides by 4. So if I plug in this into the original, -3/4 times 4, the 4's cancel again, we get -3 minus 6, that's -9. The absolute value of -9 is +9, so this works as well. So these are our 2 solutions. So that's an example of one where we had to do something first before we could just jump into solving that equation. Now, let's look at the last one. Again, let's move this over, get some spacing in here, and we'll take a look. With this one, I want you to treat it just like we did with the two-step equations that we used to solve. Kind of put a little box around this, just like you used to put a box around, the 6x and get rid of anything else. We're doing the same thing with absolute values. Put a box around that whole expression, including the coefficient, and get rid of anything else on that side. Now, I see a plus 5, so I'm going to get rid of that first. And it looks like we have this. Now, if you look, there's still one more step we have to do. We've got this 6 that we now want to get rid of just purely by division. Okay, and now once we do that, we should end up with the absolute value of x plus 3 is equal to 5. Now that, perfectly fine. We have an absolute value equal to a positive number. Now we can get to work solving this because it's not negative on the right side. So x plus 3 equals 5. X plus 3 equals 3 equals negative 5. And then we solve like normal. Now subtract 3 from both sides. You should be comfortable with this. We get x equals 2. Subtract 3 from both sides here, we get x equals negative 8. Now let's go back and double check. 2 and negative 8. It's not going to be very fun to plug in up here, but let's try it out. Let me lock this in place, and we're going to try x equals 2, x equals negative 8. So when x equals 2, we get 2 plus 3, that's 5. 5 times 6, that's 30. 30 plus 5 is 35. So 2 works. Put a little check mark. 2 works. And negative 8. Negative 8 plus 3 is negative 5. The absolute value of negative 5 is positive 5. Okay, so positive 5 times 6 is 30. 30 plus 5 is still 35. So be careful with those negatives. A lot of students forget, oh, the absolute value of, negative 5 is positive 5. They'll try and make it, keep it negative 5. But you got to remember, absolute value takes any negative number and spits out a positive version of it. Okay, that's exactly what the absolute value operator is. It gives us positive numbers. And that's pretty much it for how we solve absolute value equations. It really is just the only extra thing is that we could have an extra solution. Oftentimes we will have 2 solutions, but there are situations where you could have 1 solution. And if you ever see an absolute value of anything, x plus or minus whatever number, and it's equal to a negative, then automatically there's no solutions to that because and I want you to think logically, well, absolute value can never give me a negative. It always gives me a positive, always. So that's pretty much it for these. We can throw some extra stuff in here, a little more algebra inside of there that you have to do. That's really all that they can add to this. The general idea is you being comfortable getting the absolute value expression by itself and then solving for where the right side is itself and then the right side is the negative version of itself. I know that sounds weird, but that's really all these are. So try the practice problems. Make sure you're comfortable with those. And again, I hope this video helped you, and we'll see you in the next one.